This is parallel connection of resistors, okay? Remember that I have started this topic from previous video. Please make sure you watch it because there were a lot of explanations there, okay? Now, this is resistors in parallel. I've done resistors in series before. Now, the resistors in parallel, look at how the connection is. The connection, you see how it is being arranged, okay? It's not like series connection. So look at it now. This is resistor 1, resistor 2, resistor 3, okay? Now, if you want to calculate the total resistance that are offered by these three resistors, the formula is this. The formula is 1 all over R equals to 1 over R1 plus 1 over R2 plus 1 over R3. This is the formula to calculate the total resistance of resistors connected in parallel. This is the total resistance or effective resistance or equivalent resistance, which says that 1 over the effective resistance equals to 1 over resistance 1 plus 1 over resistance 2 plus 1 over resistance 3. There are some points you need to take from these resistors connected in parallel. One of the points is that when you connect resistor in parallel, the total resistance which you have calculated from three of them will be smaller than the smallest resistor there. Just like these resistors here, this drawing here, we have 3 ohms, 4 ohms, and 2 ohms. If I calculate the total resistor of these 3 resistors here, the value I will get will be smaller than the smallest value here. The value I will get will be smaller than 2. That is what I mean. When you get your total resistance, from the resistors connected in parallel, the total resistance will be smaller than the smallest value of the resistors connected in that your circuit in parallel, okay? So it will be smaller. Then you don't want too much opposition to the flowing of the current, or if you don't want too much resistance to the flowing of the current, you have to connect your resistors in parallel because it will offer smaller resistance than series connectors, than series connection, because series connection will give higher resistance. Series connection will give higher opposition to the current than parallel connection of the resistor, okay? Then another point you have to pick from here is that the voltage flowing through of them, the voltage flowing through R1, R2, and R3 will be the same. It will be the same. Just like in a series connection I've explained, the voltage flowing through them is different. But here, in parallel connection, the voltage flowing through them are the same, just like opposite. It is opposite of a series connection here. The voltage flowing through them will be the same. But current flowing in the current flowing through these 3 resistors will be different. Will be different. The current flowing here is different from the current flowing here, is different from the current flowing here, just like opposite of in series, because in series it's the same current flowing. Why there is different voltage. But here in parallel connection, there will be different current while there is the same voltage flowing in them, okay? So this is the formula. For example, if you are being given these resistors that are connected in parallel to find the total resistance. So you now say calculate the total resistance of these resistors here. The resistor 1 is 3 ohms, the resistor 2 is 4 ohms, and the resistor 3 is 2 ohms. Now calculating for the effective resistance, we now start by saying 1 all over the effective resistance equals to 1 over 3 plus 1 over 4 plus 1 over 2, which we now find the LCM of these three numbers of the denominators. The LCM is 12. We now have 1 over R equals to the over 12, which is the LCM. We now say 3 divide the 12, which is the LCM of the three numbers, it will get 4. The 4 it gets times 1 up will be 4, plus 4 divide 12 to get 3 times the 1 up. 3 times the 1 up will be 3, plus 2 divide 12 to get 6 times the 1 up. 6 times the 1 up, it will be 6, which is when you add them, 4 plus 3, 7, plus 6, 13. You now have 13 all over 12, which is 1 all over R equals to 13 over 12. We do cross multiply in order to find the effective resistance, okay? Now, we now have 13 times R will be 13 R equals to 1 times 12, which is 12, making R subject of formula. We now have R equals to 12 all over 13, okay? Which is, when you find the value, it will give you 0.923 ohms approximately, okay? This is the answer. You can get it in this way again. You can do 1 over R equals to, then you now use your calculator to divide. That's 1 over R. You now say 1 divided by 3. It will give you 0.33 approximately, okay? Plus 1 divided by 4. 1 divided by 4, it will give you 0.25, plus 1 divided by 2 to give you 0.5, okay? Which when you add them, it will give you 1.08. Then you now have 1 over R equals to 1.08. So trying to make this one subject form, I do over 1, do cross multiply, okay? This 1.08 times R will give us 1.08 R, which is equal to 1 times 1, 1, okay? Making R subject of formula, we now have now R equals to 1 over 1.08, and when you divide it, will give you the same, approximately 0.923 ohms approximately. But it still give us the value if you decide to do it this way, right? There's nothing changed, okay?